Okay, number one, transverse pulse. The motion, so for the transverse pulses, the particles are pushed like perpendicular to the way um, the object is going, so the pulse is going. So say the particles are going like to the right as the wave itself is moving forward. So they're moving like perpendicular. And then how does the shape appear to change? At first it starts off like a real defined crest, and then as it moves, as it keeps going on, it looks like it becomes more like rounded. And yeah, what's the difference? Or does speed appear to change? It looked like it kept going at the same speed the whole time, but it might have gone slower. I couldn't really tell from the video. Number two, longitudinal pulse. For longitudinal pulse, the vibrations kept going in line with the wave, so the particles would run into each other. They didn't go perpendicular like the transverse pulse does. For the different amplitude videos, the initial amplitude the initial amplitude of the pulse depends on how far the slinky or wave is pushed or pulled from the starting point. So if it's pulled like a little bit, then it's going to be a small amplitude. If it's pulled a lot, then it's going to be a bigger amplitude. And the speed doesn't depend on the amplitude. Frequency videos. Is the wave speed different for the frequencies? The wave speed seemed the same for the different frequencies, and for the contrasting the waves and frequencies, when the wavelengths grew shorter as the frequency grew faster. Slinky and then for the different distance videos, the amplitude seemed like it might have been a little bit bigger on the shorter distances. What did changing distance presented to attention? And then changing the distance, the wave traveled differently because it was more attention, so it seemed like it went faster at the end, by the 3 meter compared to the 6 meter, and the crest was a little bit bigger for the 3 meter. Yeah.